Hi, fifth and seventh period. How you guys doing? I was here for first and third, but I have a very boring meeting, fifth and seventh, so I will not be in class. So we'll have a sub. So today, that's what we're going to do. Our objective, this is what we're going to want to be able to do. Describe what makes water a polar molecule. Why is it polar? And how that affects cohesion and adhesion. And we're going to do this with a Gizmo's Sticky Molecules lab. Also finished the enzyme review packet. I went over that on Friday, so I'm guessing 95% of you guys did it. If you didn't, I don't know, maybe you're absent or just weren't paying attention. I'm gonna kind of get you started on this Gizmo sticky molecules. It's kind of confusing. So if you get confused, you get stuck, don't just sit there and do nothing. Go to the next one. Just try to do your best, get as much of it done as possible. If I get a great report from the sub, great. I might give you a movie day. So say fifth period gets a bad report, seventh period gets a good report. Fifth period, you'll have an assignment. Seventh period, I might give you a movie to watch. And it could be it could be flip flop. Maybe fifth period has a good report, seventh period has a bad report, then fifth period will get to watch a movie, and seventh will have a long assignment. So it'll be good for the sub. All right, real quick, I'm going to go over, get you started on this Gizmo sticky molecules. Now we're just going to do our best on this. So if you get stuck, skip a section, go to the next one. Just we're going to try to get as much done as we can. So the best way to do it, one partner have the Gizmos, document open, and the other one have the actual virtual lab, and then you just one person does the virtual lab, the other person does the typing. All right, so I'm gonna get you started. So this one right here, it says drag a bottle of water and a petri dish, and we're gonna put water in the petri dish. So I go here. All right, so the petri dish is right here. It's this thing. It says polarity. We're gonna drag it here. And I'm gonna drag water up here. I'm gonna put some water in the petri dish, and it's gonna allow us to see the water molecules. And here they are. All right, so the red part of the water molecule has a negative charge, and the blue little ears have a positive charge. And we're looking if they form bonds, and that's the little yellow things, like right there and right there. They're forming hydrogen bonds right there because the negative region of one water molecule is attracted to the positive region of another water molecule, and they stick together. Those are hydrogen bonds. And you can try it with like hexane, and let's see. So water's polar because it's making hydrogen bonds. Let's see hexane. They're not making any bonds. There's no little yellow lines. So these guys are not attracted to each other. So they're non-polar. And you're going to do it with glycerin, do it with mineral oil. Then let's go down. Petri dish. Do your best on this. I'm going to do this one, the drop diameter. So I go here. This is a different one. So I hit reset. For the drop diameter, I'm taking this. This is wax paper. I'm going to put it up here. I'm going to put water back up here. And then the smaller, if the drop doesn't spread out, it's usually polar. So boom, look at the drop of water. It didn't really spread out, so I measure it, and it's about 5 millimeters. So put a 5, and then let's compare that to say hexane. Now, if it's non-polar, it's going to spread out. The drop's going to spread out. So let's see hexane. Oh, look how far it spread out. It didn't stay together. So so hexane is not, they don't make hydrogen bonds. Hexane molecules are not attracted to each other, but look, it's about 18. So I put it right here, 18. All right, so you're gonna get all the, do it with glycerin, do it with mineral oil. Let's see what else we got. Do your best on these. The tilt angle. This also is another like measurement to see if something's polar or not. So I bring this tilt angle, I bring it here. I'm gonna start with water. I put a drop of water on this little tilt meter, and then I start adjusting the tilt slowly, 1 degree. The more it hangs on, so eventually it's going to slip off. But if it's attracted to that surface, it takes a long time before it slides down. 13 degrees, 14, 15, 16, 17, 18. Boom. Oh, I had it. 18 degrees and it slides off. So for the tilt angle of water, it's 18. And so for these other ones, let's try mineral oil. Boom, put it on here. Put a drop. Slowly start tilting it. Deet, 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 deet. Slowly, and boom. It only took 8 degrees. So mineral oil was only 8. And let me go through one more. Let's do the surface tension one. Surface tension. All right, so to do that one, you go here, surface tension, take it up here, start with water. So I put water in here, and I'm gonna start pulling on this little crank. And I'm looking, pulling this crank up as that little thing comes up. You'll see that there's some water in there, and we're waiting for the water to fall back down into the petri dish. So it's still there, still there, still there, still there, and still there. Boom, it fell down. 34 newtons. So for the This one will be, oh, actually for the tilt angle, I got this one screwed up. This one's 34 newtons. All right, so then you're going to do it with hexane, do it with glycerin, do it with mineral oil. All right, so we're going to try to do the best we can. If someone gets this all done, I'm giving you a bunch of extra credit. But if we can just get most of it done and you're just working hard and the sub is happy with your behavior, I'll be a pretty happy guy on Thursday. So do the best you can, get as much as you can done, and I'll help you out when I'm back there on Thursday. All right, so you guys have a good day, and I'll see you Thursday.